What if I told you that your brain doesn't just see the world, it creates it? Welcome back to DeepVisus, where we explore the profound intricacies of how we experience the world around us. Today, we're diving deep into chapters 3 and 4 of Stephen Grossberg's Conscious Mind, Resonant Brain. And our main question today is, how does the brain construct the visual reality we experience? At first glance, the act of seeing seems like a simple process. We look at the world, light enters our eyes, and we register what's around us, right? But according to Grossberg, seeing isn't passive at all. It's an active, complex process where our brain constructs the reality we perceive. So how does this happen? Let's break it down. The first key concept we need to understand is boundary completion. Imagine you're looking at a person standing in front of a tree. The boundary between the person and the tree, where their silhouettes meet, is the boundary. But here's the twist. Sometimes the visual information we receive about these boundaries isn't complete. There might be parts of the scene blocked by other objects, or perhaps parts of the boundary fall into our blind spots. Now, the remarkable thing is that despite these gaps in visual information, you don't see those missing parts. You don't see the missing boundary between the person and the tree. Why? Because your brain fills in the blanks. Grossberg introduces the idea that the brain uses something called boundary webs to accomplish this. These boundary webs are invisible constructs formed by the brain to connect fragmented visual cues across space and time. The brain takes small, disconnected pieces of visual information and forms coherent boundaries, completing the edges that would otherwise be invisible. It's like the brain is an artist, constantly sketching the outlines of objects that might not be fully visible. And here's the kicker. All boundaries are invisible. What we perceive as solid, sharp edges, like the edges of a tree or the person's body, are actually constructions formed by these emergent boundary webs. The brain doesn't simply see edges as they are. It actively builds them based on the available data, drawing lines where necessary to complete the image. But boundary completion is just the first step. The next crucial part of how the brain constructs visual reality involves surface filling in. Imagine this. You're looking at the surface of a red apple sitting on a table. We see the apple as a continuous red surface, but what happens when parts of that surface are occluded? Let's say by a shadow, or a reflection, or even by something blocking the view. The apple is still perceived as a continuous, solid object, even if some portions are hidden. This is where surface filling in comes in. Grossberg explains that our brain doesn't just fill in missing edges. It also fills in the color, texture, and even depth of the surfaces. It's as though the brain is painting the missing parts of the image based on the context provided by surrounding areas. Surface filling in is a process where the brain extends information about brightness, color, and texture from visible areas to areas that are occluded or hidden. Think of this like a puzzle. Your brain doesn't just solve the boundary. It also fills in the gaps between those boundaries to make the object complete in your perception. Now, the fascinating part is that boundary completion and surface filling in are not separate processes. They are complementary. Grossberg reveals that these two systems work together in parallel to create a unified perception. The brain doesn't process boundaries and surfaces independently. Instead, they cooperate and compete with each other to create the most coherent visual representation of the world. This complementary relationship is key to understanding why we experience the world the way we do. The brain doesn't just rely on a single stream of visual data. It processes information across parallel systems, one handling boundaries, which are concerned with the edges and shapes of objects, and the other handling surfaces, which deal with the texture, color, and depth. These systems are organized in parallel streams that work together to build the world we see. One stream processes the shapes and contours of objects, while the other stream fills in the details, like color and depth. It's this balance between the two systems that allows us to see the world as a complete, three-dimensional space, despite the fact that our eyes receive fragmented, incomplete information. But there's more to it. Grossberg introduces a principle that he calls hierarchical resolution of uncertainty. This is the idea that the brain solves visual problems by first handling them in a fuzzy, uncertain way, and then sharpening the final percept over time. When the brain first processes visual information, it might not have all the data it needs, but it begins working with whatever is available, creating a rough, fuzzy representation. As more information comes in, through feedback loops and interactions between different brain areas, it refines the perception, sharpening it into a stable and coherent visual experience. This process happens constantly, often without our conscious awareness, ensuring that our perception remains stable even when the visual data is incomplete or uncertain. So, how does the brain construct the visual reality we experience? It does so by actively creating boundaries and filling in surfaces, drawing from complementary systems that work in parallel. The brain builds the world around us through these dynamic, ongoing processes. And these processes don't just happen in isolation. They are part of a larger, hierarchical system that sharpens our perceptions over time. If that didn't blow your mind, stay tuned. In the next episode of DeepVisus, we're going to continue exploring how these processes come together to shape our 3D perception of the world. We'll dive deeper into how the brain interprets complex visual data and how it uses feedback systems to stabilize perception in real time. Until then, remember, stay curious, stay sharp, and keep diving deep because DeepVisus is where vision meets depth.